Hello guys, so today we'll be solving some more 1300 problems. Okay, so this was the first question. I just solved it right now. I solved it. It was a very easy question. It can be solved using lower bound. Uh, Basically, let me show you. Basically, this was the question. For every element of the bth of the um, B of the second array, we have to find number of elements that are less than in the array A, less than or equal to basically. So basically, what I did is I sort the first array here. Then for each and every value of the second array, I got the upper bound index. So if all the elements are less than this element, we will get n here, which is the length of the first array, and also we'll get a index which is just greater than this number. So if we get an index which is just greater than this number, that means all the elements less than this index will be basically less than or equal to this particular value, right? If we get for example index, it returns I, then all the I minus 1 elements will be less than or equal to BRR of I, because it is an upper bound. It doesn't search for the value which are equal to, right? Okay, very easy question. The second one was little girl and the game. Basically what it was is we are given a string s. Now there are two players. The player moves in turns, right? In one move the player can move an arbitrary letter from string s. Basically he can remove any of the letter from the string. Now this or what he can do is he can choose to reorder the string s to get a palindrome. Now this was an observation question. Basically if you write down a few cases you will figure it out. I solved it using this idea. Basically previously I was thinking something along the lines of frequency array of something, but it can be solved without that also. Some I was thinking of maybe keeping a set or something and removing the values. So basically what it means is you are given a string here. Now a string will have even values, basically even amounts of A's or even amounts of B's, like that, and it will have odd. Now as you know, in a palindrome, even numbers can, like even amount of characters can always form a palindrome, right? If we get A, B, B, it will we can always form a palindrome using this, right? Because it will be A, B is the palindrome, right? Any amount of even numbers, even amount of even characters. Now for the odd is um, the thing is you can't construct a palindrome with more than let's say uh, if there are four odd elements, right? Uh, like if there is, for example, there is a string A, B, C, D, you can't construct a palindrome, right? But if there is A, basically it is odd number of elements, but one element can be placed in between, right? That's the main idea. You have to figure this out, because let's say if it was A and B, 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 it we can't form a palindrome, because even if you put it like this, A, A, B. Now where we can place one B? Now we can place, we can't place here, we can't place here, we definitely can't place here. So this is the main idea. Basically, the odd elements have to be equal to 3. Now if odd elements are equal to 3, we have seen we will get a palindrome. If the odd numbers are equal to 1, now we will definitely palindrome, right? Even if there are no even elements present, let's say even is 0. So if it's a, it's a palindrome. It's odd number of elements, which is 1. It's a palindrome. If it's B, B, A, we can arrange this B, A, B. It's a palindrome, right? And one more case is one zero or zero odd elements. So we will definitely get a palindrome. A. It's a palindrome. Now this was the main idea. Basically what I did is I first stored the frequency of all the characters. Then I checked if, for example, which of the characters are occurring even number of times. Then I added in my even count. Else, if it is occurring odd number of times, I uh, basically added it to my odd count. So in the odd, you can see these are the only three cases which will suffice to an answer. Else, you can't get an answer from any other case of the odd. So if I check if odd is equal to 0 and even equal to 0, basically this was the base condition so that the loop doesn't run infinitely. Now this is the main condition. If odd is equal to 3 or odd equal to 1 or odd equal to 0 and even is even. For example, if you get, for example, you are carrying even here, right? And you are carrying one odd. Now let's say this way. Okay. Now the player one comes and he sees, okay, right. He will no, not this. Let's go with the 1 second. Let's go with this. Okay. Now the player one comes and he sees, okay. Now if I remove this C, right, will I get a palindrome for the next player? Of course he will get. If we remove C, the second player wins because this can be easily arranged to palindrome. Now he says, if I remove B, will I get a palindrome for the second player? Yes, you will. Now then there's only one option left to do. It will be to remove one even character. Now you see the even count. Even count was previously uh, 1 second. Even count was 4. Odd count was 2. Right, for this particular case. Now this is the test case, right? Even count is 4, odd count is 2. Now we have to remove this A. Now the even count will become 3. So basically you can see even if it's even, it will become odd once we remove this character, right? Because this is the string we get. Now if we remove this, right, we won't get a palindrome using this. We can't, right? We can't because this is the situation, right? Now so that's why what we are checking here. If after removing any character, the even basically the even amount of characters, uh, if we are left with even characters or not. If we are left, then it's basically the flag which are setting. If flag is false, then the first player wins. If flag is true, then the second player wins. Easy peasy. Now here this is the conditions basically. Like if it's odd equal to 3 or odd equals to 1, even minus minus f is equal to not f continue. Basically what it means is basically if we get one of these two conditions, right? For example, this was for what case 2 can we take? Let's say okay, let's say it's a b b b. Right now the person comes here and he can't even if for example let's say this was not here, right? We have to remove even. uh, B, no not 1 second, not this. Okay. A, and C, and this was C, 1 2 this one is no, this won't work. It's A B A works. A, B, E. Okay, I'm not able to come up with the currently the test but it was like if one of these values there, then we basically what we have to do is we have to remove this. Um, basically we have to remove um, the even characters, not the odd characters. So that's it. I would see. This means that even if yeah, Okay, so even if the even is not uh not even. See, in this case, we are only removing even when it's even, right? When it's like even number of characters. Now this says that okay, you see odd will 3 not equal to 1. If let's say even is odd, right, and one of these conditions come here. For example, the string is a sorry a no, not this this work. No, to one. Basically it means that even if my even is not even, right? If even is odd and one of these conditions become like is there, so that means my odd number of characters odd become one. Oh, sorry, even, because see here odd minus minus. Now 3 minus minus is 2, or 1 minus minus is 0. So odd can become 1 and even is odd. So that means one of the even character can come here and form a palindrome. So it is not optimal to remove. So we have to remove this even here. Alright. I think it can work without this also. Because the player, the upcoming player will win regardless, right? Uh, I think so. But okay, let's see the tutorial. I haven't even seen the tutorial. Let's calculate the number of occurrences. Let this value be k. If k equal to 0, odd number of occurrences. Let's prove k second player is a winner. Yeah, it's the same. If k is equal to second player is winner. Yep, that's I think that what they are doing. Okay, have they given any solution for this? Okay, so I did not that. Okay, no issue. Now we'll come to the next problem, car and last class of math. We learned about our LCM. Small one. Okay. Okay, this is completely my question. I'm very bad at math question. I'm trying to improve, but very bad. Mm, okay. Mm, let's see. Um, and LCM of A and B is the minimum value possible. So, okay, minimum possible. And A plus B equal to N, and we'll use this. Okay. Now, what is the formula for that? It says O into B divided by HCF is equals to LCM, right? Now, it's divided by HCF for this. Okay. Hmm. So once we get two numbers, A and B, mm, basically, if we were to run this loop through, uh, and we have to get the HCF, and then we'll get the LCM. So the LCM, we want it to be the minimum. That means the HCF would have to be the maximum, right? Hmm. Okay, that means what we're saying here is LCM should be minimum, then HCF would be maximum, right? Between two numbers, and A plus B should be equal to N. Uh, okay, so A plus B should be equal to N. Okay. Huh. All right. And once we get, let's run a few cases here. Then you can get a better idea. For example, let's go with 9. The second case is the longest apparently. Let's go with the second test case. Okay. So in this equal to 6, we have a few ideas. A, B. A can be say 1, B will be 5, 2, 4, 3, 2. Right. This will be the values here. Now you see, okay. Mm, and apparently the minimum, like the maximum FCF, just for this FCF is 1, both prime, right? For this FCF is 2, 3, 2. No, sorry, it will be 3, 3, and the FCF is 3 here. So of course we are going to take this because it will. Now we have, see, if if the number is even, then I think it's easy because the maximum HCF that we can get is I think 1 by 2, right? Okay. Now what? Now if the number is odd, that's where the main thing is. That's where everyone is. Okay. Okay. It's 7, not 7, not a prime number. Let's go with this. 9. For 9 it will be 1, 8, of course. It will be 1. It will be 2, 6. It will be 2, 3, and 5 will be 1. 4 done. 6 and 2 is done. 7, 1. Sorry. Sorry, what? 2, 6. What am I doing here? 2, 7. 3, 6. Will be 3. It will be 1. 3, 6. 4 and 5. It will be 1. Then will be 5, 4. Just show us. So the answer should be here 6, 3 and 6. The answer should be 3 and 6. Okay. Alright. So the answer would lie somewhere around this range only. This n divided by 2 range. Because alright. First I have to check if it's a prime or not. But it doesn't matter if it's a prime or not. We have to get a plus b. So if it is prime, then no. If it's, for example, 13, right? 7, 6, 6, 7, 9, 4, 11, 12, 2. The answer can be 12, 2. Okay, it's odd, it's prime. Alright, if it's prime, then the answer would be basically 3. 4 and 4 plus 5 is plus 6. It doesn't make sense. Uh, it can be solved in big of 1. That's what I'm thinking. Hmm. If I were to hmm, hmm, this is a pretty fast operation. So we'll take log n. Okay, wait, we have to get the maximum. We have to get the maximum, right? So, uh, now to avoid this multiplication, what you can do is first you can divide it by pi. I think it won't run into overflow. Then okay. Um, sorry, my is um equals to um maximum of LCM and the um, maximum of LCM and answer. Yeah, answer and then okay. It's pretty slow. No, my system is very slow. I don't know why. It's in the restart. Okay. Right. Slow man. 2, 3, and 14. Okay. Alright. What am I returning? Okay. 2. Why this is not even appear? Okay. Oh, sorry. 2 and 7. Showing me 2 and 7. Right. Why it's 2 and 7. The square root of 9 is 3. It should run till 3 and it should get the answer of 3 and 6. Why this is happening? It's running till 3 apparently. And let's get the GCD actually. GCD. The aging should be minimum, right? Array. What am I doing? Hmm, Let's try one. Yes. Alright. Oh god, please pass. Okay. Answer. Expected 496 from 510. Alright. Okay. 527. Hmm. Okay, it won't run till 31, that's for sure. Okay. Figure because 30 square is 900. What can we do? I suppose since we are on the right track. Just it's only big of one, I think. I'm not able to find it. Ah, this was the this will definitely not work. It will just give up DLE. Mm, yeah, the answer is working, but it would just give DLE. Right? Doesn't make sense to do that. Uh, how can we optimize this? Now, this solution works. We know that we are on the right track. I'm just missing very small thing. Um, what am I missing? This kind of looking. It's taking. What the hell? Okay, what's this? Please. Okay, nope, doesn't. Okay. Uh, when should we stop really? Like, um, we not tell M, but we won't find any pairs. We will, whatever the pairs we find will be at this only. So, if M by 2, then the next one is by 2 minus 1. Uh, even if I were to bunny hop, it won't work. Um, okay, so what can we do here? Okay, okay, that is hard. It used to be easy, but what am I missing here? So, What happened? Yep, really. That's what I expect. Uh, so what can we do here? I'm not thinking correctly. I'm on the right path. I'm just not thinking. Um, okay. On by two. It should be. Can I create one? What do you call it? Should I pre-compute this? Will pre-computation work? If I were to, because see, I think it would remain same, right? If I were to pre-compute even. Mm, I don't know. What can we do here? Mm, 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 mm. If I were to pre-compute this all, then will it work? Then it would just be a bigger one operation. I can pre-compute this very. Mm, and again, there will be some info. Mm, very easy question. Mm, I think ultimately there is I know that the answer would be factor, right? Because the answer would be a factor. Maybe if we calculate the factor of these, then like instead of iterating over the n, then we can iterate over the factors. Factors, as you know, can be calculated in square root of n times. Yep, I think that would be the answer. If I would look at it, the factors. There is, uh, what am I doing? Here we can have two factors because we can have n by 2 and n by 2. So that can also be one answer. Now instead of iterating, I can go on this on this two dot x, and the answer would be mm, what number can I, so that was instead of taking off this answer, what we can do here is instead of fine, fine, and so that's the only change we need to make, right? Because previously we were considering each and every number, now we just considering factors. So I think this should work. Why is it 527 0? What? Why there is even a zero here? What the hell? Okay, we pushed it. Alright. No, 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 wait a second. What? I didn't push. Hmm? Yeah, I didn't push I. Uh, okay, I push. My bad. Then we need to if 5 equals to n, then to continue. 496. I think this should work. Mm, Running a test for. Let's see. Oh no, TLE again, right? Oh no, why is again a TLE? What? How is this possible? Brother, this can't hit TLE. Surely not. What? How is this fucking TLE? Doesn't even make any sense. Arey yaar, why am I iterating into this? Sorry, this should work now, guys. I'm just stupid. Okay, this works. Okay, okay, let's see any more context coming up. We have to give these, this, this. Okay, blue dust. It's a blue dust contest, so it's going to be difficult. You can say that. Okay, blue dust is the good. Mm, okay, anti-Sudoku. I don't want to do this. Okay. As anonymous arranged line, these elements are present by two integers. The value of the element and P of I, the type of element. Two type of elements you want to sort the elements non-decreasing values of A of I. Remember that. Non-decreasing means you can see even the form that remove two elements I and J has that P of I is not equal to P of J. Huh. Oh, 1 second also. Let's I need to update it into my Excel. So basically this is the Excel that I have maintained. So yep, maths and I just write whatever the first thing I thought of, basically the first idea. It was to Yeah, select into elements with that construct them to different element from values and not decreasing up after following any number of items. Okay. Hmm. Increasing passion and what you can do is okay. Increasing passion you also do this. Mm. I think my keyboard has low battery. That's why it's not responding very fast. Okay. Now okay. So that's how it's already arranged. So what we have to return. Or we just have to return yes or no. So we can perform any number of operations you want. Alright. Now you see we can't swap them. So and you see and you see one more thing that if I were to mm, swap, let's say in here, if I were to swap this and this, right? If I were to swap basically 0 and second index, right? Then will, it would give me 2, 3, right? Now this is again not second. Then I would need to swap in. You see, if I were to swap again, right? This same index, then I would reach my unsorted array. So I think we need to we can perform same operations once, मतलब in a row consecutively. You can't perform the two operations consecutively because it will just return to back to where so it won't be much valuable to us because we need to reach the sorted array and hmm, okay, the answer should be what is the answer? It's yes. Okay, we can swap this, then we can swap that. Right. Hmm. Okay, this is sorted, and this is we can't sort. Okay, so hmm, okay, if any element has 0, okay, if for example, let's say there is one index. This is I'm writing the B array 0, 0, 0, 0, 1. Now it's unsorted, right? Now what you can see is can I swap these and these? I can swap. Okay. Can I swap these and these? I can. Can I swap these and these? I can. And I can swap with any of these. Right. Now let's suppose after swapping, then swap basically 0 index and fourth index. Right. Then the answer then we would get here equals to 1, 3, 4, and 5. Right. Now you can see I have arranged this particular number in its correct position. Hypothetically, let's say this was this number was supposed to come here. Now I have swapped this number and I have like put it into its correct position. Right, I have done this. Now you see here, this is an incorrect position. It should come here, right? Then I can swap these also, right? And let's say even if it's not supposed to come here, let's say if one is supposed to come here and this needs to go here, then what we can do is first we can swap these and this. So this will basically become, so what we can do is swap, I think, 0 index and second index. So we would get something like 0, 1, 0, 0, 0. Right? We would get something like this. Sorry, sorry, my bad. 0 and 1. Right? Now, basically, and this needs to go here. So now we can swap these and this. So swap uh, 1 and 2 index equals to 0, 1, 0. So this so what we can see here is basically it's like a intermediate node. For example, you are at A, you need to go to C. Alright, you have to choose a path which uh, either you will not be able to go to or you will be able to go to using B. So that means particular this alternate node. Now this is, sorry, this is become very easy now. We just need to check. Um, First of all, ULL CRR is equals to ARR or CRR. We can do this, or what we can do is let's do that. No, suppose and human plus plus. Now this is need to be increasing. So of course, if ARR of 5 plus 1, if it is less than, right, ARR of 5, then it would be a shame and it would not be a non, it would be a decreasing, basically not increasing such a array. So we say f equals to true and we would just say break. Now if f, if not f, then we can just simply say that yes, this is my answer. It can be sorted and it's return yes and no. Okay. Else, what we can do is we need to check. Um, no, wait. Mm, uh, no, no. One equals to 0. Would be uh, for example, if it's a single array, it wouldn't matter, right? If it's so what we can say here is if z equals to um, basically 0, 1 equal to 0, then we can say that okay, we can't sort it, and the answer would be no. Okay. and then the job we want. Yes, and now yeah, and then oh shit, no. Yes, no, yes, no, no, it's wrong. Yes, yes, no, yes. Yes, why this is giving us no? Why? What the hell? Huh? It shouldn't give us no. Why it's giving us no? Um, sorry. What counting is wrong? See, wow, it's 0 and 1, and that is 0. Why 0? At 0. Why do mean and we are entering. Yep, that seems fine. Then we come here. We have put the value of z. Z can't be 0. You can see 0 is present here. Like, 0, 5, no. It's going into this, but it's not going into this for some reason. Why? Okay, it's breaking here. Oh my days, I'm so bad. Yes, 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 no, yes. That's fine on this. Okay. Thank you. Let's wait. It has become slow. La 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 la. Test one. Let's see. Only one test one. Still. 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 Okay, it's now slow force. Yes, apparently. I should pass. This should work. I hope it won't fail here. Okay. Okay. Alright, accepted. Let's see the tutorial once. Hmm. We are going to trouble sort and see if there is at least one tech element. We can always sort the array. Right, it's the same solution. Alright, good observation. Kudos to me. Okay, I think we have done. Let's see how many questions we have done today. Yeah, one, two, three, four, five, six. Yeah, we have done enough questions. Let's see one more. Alright, this is something. What does this even mean? Hmm, For all, I think it means for all I greater than 2. Is it? Oh, Fibonacci. I think it's kind of Fibonacci thing. We have to get a 5 1 5 minus 1 plus f of I plus 1. And basically, generally, if I will get the values. So I think you can use contribution technique here because uh, this I it for example it's infinite, right? So no, it's not what we have to do. We have to calculate f of n, and we are given x and y. Okay. Mm, and the f of I plus 1. That's a very interesting format. Okay. And the f of I plus 1 will always contain the f of I minus 1. That we can say for sure. Right. Okay. Hmm. And this f of I plus 1 uh will contain x, it will contain y. Then it would again contain x somehow. How we are calculating that future. For every future there will be a future. So how can we do that? Huh, interesting. Uh, there is a very, I think there is a very neat trick to this. Uh, okay, we will do this tomorrow. Okay, okay. Thank you guys. Thank you. Thank you so much. All right. Good night.